Hello everybody, today I'm going to show you all a little trick I came up with in Python to fix my audio clips for when I make videos. I make videos fairly frequently, and now we're going to watch a clip of one of my recordings.
So, cats taught me how to read. Chum rips up.
So, in this clip, there's a lot of noise in the background. The skateboards kind of muffle out the sound of his actual voice. And the way I fixed that was I stood right around here with a microphone, and I told him just talk to the camera and pretend I'm not there. As we'll see right now, my microphone doesn't record sound normally, and you'll only really be able to hear this through your headphones.
Cats taught me how to read. Chum rips up.
If you had your headphones on, you would notice that the sound from this clip only comes out of one side, and that's what I need to fix. Before we get into this, I'm just going to show you the old way that I use to fix the audio clips. So what I do is I would manually open up Audacity. I would import the clip that I'm looking for. And if I play it right here, you'll see we still have the problem with the audio.
Taught me how to read. Chum rips up.
But if I click here and go to split stereo to mono, that fixes the problem.
Cats taught me how to read. Chum rips up.
This is no problem with just one clip, but you see here I have a lot more than one, and ideally I would like to not do any manual labor when I need to fix my audio clips. Python has a nice module called socks that lets us do processing on audio clips. So if I make a file, main.py, and I import socks, just let me make sure that it's working. Alright, looking good. So the problem with this is that the audio is only coming out of the left side of your headphones, and channel 1 is the left side and channel 2 is the right side. So our goal is just to copy the audio from channel 1 to the other side. And so in other words, make channel 1 and 2 play the same audio. And Socks already has a class that can let us do that. So if I open up PyDoc here, and then I go to Remix, we see that the remix function lets us remix the channels of an audio file, which is exactly what we need. So what we're going to do is we're going to instantiate a member of the transformer class with transformer. And let me just run that to make sure it works. Okay, good. Everything's still working. So we see that the first parameter that Remix takes in is a remix dictionary, and they give you a little blurb right here to kind of show you an example of how you would use it. But since I already know how to use it, we'll call this the fix write audio dictionary. So the way it goes here is channel 1 of your output file will get channel 1 of your original file, and then channel 2 of your output file will also get channel 1 of your original file. And then we just pass it into the remix method like we have here. And we see here that they have another optional parameter called num output channels. And if I just leave that as none, it'll infer from my remix dictionary how many channels to put in the output. And then usually after I write every line of code, I like to run it just to make sure I didn't break anything. So we're still looking good. So now we have a transformer object, and we've applied the remix effect. And the way we actually use it on one of these audio clips is using what's called the build method. So the transform class also has a build method, which takes an input file, or the file that you want to process, and then you also supply the name of the output file. So we're going to call build. I'm going to look at that clip I was using earlier as an example. So it's called zoom 0023.wave. And then I'm just going to call the output fixed.wave. So everything looks like it should be working. I'm going to run the script real quick to make sure that it does process this file and then give us this file back. So it ran through, and then at the end it just said hello world, because I keep it here to make sure that it terminates the whole script. And if I now click on fixed.wave,
Cats taught me how to read. Chum rips up.
we can see that the audio is fixed. The good thing about programming is once you figure out how to do something once, you can just put into a loop and do it for 100 times. So now I'm just going to comment everything out and save it for later. Actually, I don't need that one. So Python has another module called OS, and inside of OS there's a function called list there, which basically, as we see here, just returns a list containing the names of the file in the directory. And if I don't give it any parameter, it's just going to use the current directory, or in other words, the directory that we're in right now. And I'll just show you all an example in using the os.lister function. So if I import os, I can say for f in os.lister. I'm not going to give it any parameter because it'll just use the current directory by default. Printf. And as you can see here, it just kind of it listed out the names of all the files that we have here. And this is going to be really useful for when I want to fix the audio for all of the files here. So we're in our code, and I'm going to start off by saying for f in os.lister, printf, and then just for my sanity, I'm going to run it again. And os is not defined, but that's because I didn't import os here. So what happens in this for loop is I'm going through the contents of the directory, and I'm calling each file inside of it f, and I could work with f later. So the OS module also has another function. There's a little submodule within OS called path, and within that there's another function called split extension or splitxt. And what it does, you'll see, is it just takes some sort of file, so my file.wave, and it'll return to you first the name of the file and then the extension of the file in a tuple, so you could play around with that. So I'm going to take the name and the extension. I'm going to set it equal to os path.splitxt f, and now I'm going to print it out just to make sure that it works. So good, I got the name of the file and then the extension, name of the file, then extension. So the thing about socks is, I think unless you install some sort of plugin, it only really works with WAV files, but it doesn't matter to me because my microphone only records in WAV anyway, or the audio device that I'm using. So I have the extension inside of the ext variable, and I can easily target all the files which end in .wav. So if extension is equal to .wav, then print the file. So now we're only really targeting files which end in .wav or have the .wav extension. So now that we know how to target all of the files which end in .wav, I can uncomment the stuff I had earlier. And then and now remember earlier that the transformation isn't applied until we call transform.build on a file. So now in our loop we could say for every file in this directory, if the extension of the file is .wav, then we'll use transform.build on that file. And remember that transform build takes in the first parameter, which is the file you want to act on, and then the second parameter is the name of the file that will be outputted. And just to make our script a little readable, I'll have the new name of the file. So now the name of our output file is going to be the original name of the file, the original name and the original extension, but I'm just going to put a little -fixed at the end to let us know that it's not the original file, and I know that this is the correct file that I want. Like I said before, the transform build function takes in first parameter, which is the input file, and we'll put in f, and then the second parameter is the output file, which will be the new name of the file. And now it's going to be the moment of truth here. I'm going to run this Python file, and then we're going to see if it actually processes all of these audio files into their fixed versions. Transform is not defined. That's because it's transformer. Oops. Okay, so I'm going to run it now. Alright, so we saw it happen right here. All of the files were processed and then transformed into their fixed versions, and I'm just going to make sure that it actually works by testing this out.
Cats had taught me how to read. Chomrupsa.
So this file works fine, but I think we can make it a little bit better. For instance, I like to see on the screen what's happening, and I also think that if a file has already been fixed, we don't need to fix the fixed version. So if I ran the script again right now, these would all be processed, but also their fixed counterparts would be processed, and that's kind of, we don't need that. And that should be really easy to fix. So we can add another condition to our if statement, and the way that's going to go is if the extension is .wave and fixed is not in the name. I would also like for there to be some sort of output message, and the way we're going to write it is fixing this file, and it's going to be called this now. So we're fixing F, and it's going to be called new name. And just let me remove all of that, all the fixed versions. And now if I run this file, it should fix everything. And now we see the messages for files as they're being fixed. And also if I run this again, well, that's no problem. It's overriding the fixed files from the previous run, but the important thing is it's not operating also on these fixed files. So that was a little trick I came up with. It's just a short 14-line script, and I can just rerun it over and over again and never have to worry about my audio being messed up. And I hope that you guys kind of get some inspiration about personal projects that you can do to help improve your own workflow. If you want to see the end product of the video, then I'll put the link in the description of my other YouTube channel. And thank you.